Hi Tom. Are you okay? You look confused.
Hey Jerry. Yeah, I do not know how to do my tutorial work.
Can I help?
I just don't understand how to work out an empirical estimate of the distribution functions using observations from an investigation.
Do you have the complete data?
I don't think so. I don't know the exact dates people died, and the data cut short some observations, so not everyone has died by the end. How can I work out the distribution function without this information?
It sounds like you have non-informative censored data. Sometimes empirical data is incomplete. You will need to use Nelson-Aalen estimator by the sound of things.
Nelson what? What's that?
Nelson-Aalen estimator is a non-parametric estimator of cumulative hazard function, based on a sample that is subject to right censoring.
Oh right. What is the cumulative hazard rate function? How do I calculate it?
It is also called the integrated hazard rate function. To calculate it, you add up all the lambda j's, where lambda j is equal to your dj's divided by your nj's, when your dj are the number of events at tj. This could be the number of deaths at this time. The nj are the total individuals at risk at tj. This is the number left that could die in the future. We use capital lambda to denote this hazard function, which looks kind of like an upside-down V.
Okay, so then how do I work out the distribution from that?
Well, you use this hazard function to get a survival function s of t, which equals the exponential to the power of minus the hazard function. Then to get the distribution function f of t, it is 1 minus this survival function.
Is that it? Is it that easy?
Yeah, just like that. The Nelson-Aalen estimator is a staircase or a step function. It is the location of the steps at each observed death time. Then it has the vertical size of the steps as 1 divided by the number at risk.
And the number at risk is the nj's, and is the count of subjects just before the death that are still observed to be alive. That means that the deaths occurring at that time j are included in the nj as they are not dead just yet.
Exactly.
What about if I need to compare these estimates with 2 or more populations?
That is an important question, as the statistical properties are important. Remember that the variance of the distribution function is itself a function, and so you don't just get one figure.
How would I work out the variance or confidence intervals for it?
Well, if you look in your orange actuarial tables book there, and you will see a useful formula on page 33. It is called the Greenwood estimate. You use this formula to work out the variance. It is straightforward, but you must remember you are only taking values of tj less than t.
Okay, thanks. And what about confidence intervals?
Well, that is easy once you have your variance calculated. You can determine a suitable confidence interval by assuming that the normal approximation is appropriate.
Brilliant. Thanks for your help.
No problem, Tom. I am happy to help.